Hello, everybody joining us today. Thanks so much for coming to this fourth and final webinar of our IT Masters and Charles Sturt University series on blockchain fundamentals with Dr. Rich Lane, one of our wonderful course mentors. This course is ending after today's session. If you have not attended the previous sessions, you'll be able to find any of those recordings in the Moodle. So you can access that at learn.itmasters.edu.au, or if you prefer, you can access that via our YouTube channel, which John has very helpfully popped in the chat. My name's Jack Stewart. I will be joined by Dr. Rich Lane, and we are assisted in the background by John, who is moderating and helping out, making sure everything runs smoothly for us. We are coming to you, as usual, from the lands of the Wurundjeri people of the Eastern Kulin Nation and the Gadigal people of the Eora Nation, and we pay our respects to their elders and ancestors and acknowledge their ongoing unbroken sovereignty and connection to lands, waters, and culture. Thanks everyone so much for joining us for this Blockchain Fundamentals final quarter of the course. As I mentioned previously, all of the course materials, so the recordings of previous sessions, as well as readings, links, the forums where everyone can engage with all of the course content on their own time as well and have their questions asked and answered and discussed with other participants. That is all available at learn.itmasters.edu.au. As this is the fourth and final installment in this Blockchain Fundamentals short course, there will be an exam that is available to you. That will be available within about 24 hours of this webinar being completed. The results should be immediate upon completing the course. And once you successfully complete that course with a passing mark, you will be able to download your certificate if you are logged in to the IT Masters intranet, the Moodle. You should be able to access that via the email address, the details via the email address with which you signed up to attend this short course. And if you have any questions or issues with that, feel free to get in touch with us. That is short courses at itmasters.edu.au. There will be one attempt at the exam. It is a 60-minute exam, after which time you will not be able to complete the course if you haven't, complete the exam if you haven't completed it within that time. And it is all in multiple choice. If you are not successful at the exam and you would like another attempt, you may be able to instead sign up again to the course with an additional email address and reattempt it via a different account. It's going to be your best option to do that. If you've enjoyed this content and you are hungry for more and you're interested in partaking in any of our additional short courses, you can also find those on our website, itmasters.edu.au, under the short courses tab. We have a variety of short courses. If you successfully complete 3 eligible short courses, that will make you able to claim 1 subject worth of course credit towards any of our full-length certifications. So that's the graduate certificates and the master's degrees. If you're interested in studying with us, we definitely encourage you to look into your eligibility. So you can email eligibility at itmasters.edu.au or navigate to the eligibility tab on our website and have a look, fill in an eligibility assessment form, and we would love to have a chat with you about not just what courses you might be eligible to study, but also any RPL, any recognition of prior learning that you may be eligible for in order to minimize the amount of time and the cost of your completing that grad cert or master's degree with us. So definitely get in touch or check out our website about that if you're interested in a full-length course. Dr. Rich is, of course, one of the mentors for several of the subjects in some of our full-length courses, and as we've previously mentioned, is a testament to the usefulness and the helpfulness of our full-length courses, as he is himself a graduate of our MBA in computing. So that should be just about all of the housekeeping. Once again, use the chat function, please, to discuss things, add points of interest, and anything that you'd like to just generally note, discussion with other participants, etc., in the chat section. And the Q&A, if we can keep the Q&A section for direct questions for Dr. Rich about the course content itself and the subjects and topics that we'll be looking at tonight. That would be very much appreciated. Once again, as well, we are unlikely to have time to answer every single question that comes through, and some of those questions may be sort of asked and answered as part of the course content. If your question is not answered tonight, please do engage in those forums on learn.itmasters.edu.au, where you can have a look at all of the previous course materials for this short course, and also discuss with Rich and with other students as well. So all of that being said and done, I'd like to welcome Dr. Rich Lane for our final webinar in this series. Thanks very much, Rich.
Thank you. Hello, everyone. It's sort of bittersweet. It's the last week. I've thoroughly enjoyed the conversations that we've had in these webinars and also in the forums. So thank you for everyone that's come and enjoyed. I might just start off and say, if you haven't seen the other videos and you've happened to land on this one, please do have a look at numbers 1, 2, and 3, or the modules 1, 2, and 3. These are basically built in a way to build on the previous slides. So this one here is more of a culmination of what we've gone through in the previous modules. So if you have just jumped to this and you're in a recording, it's probably better to do that first. So I'm going to introduce myself. My name is Richard Lane, Rich Lane. I'm currently the Chief Technology Officer at two companies, Orange Cow and DataIT. As stated, I did my MBA at Charleston and IT Masters. I actually started my whole, I guess, secondary, well, let's just say tertiary education based on a short course. So a short course got me into everything that I've done now in terms of my education. So, and I went on to do my DBA because I'm a glutton for punishment, but I thoroughly enjoyed that as well. I'm currently a casual academic at UTS. I've got some blockchain patents and I won some awards. I'm going to skip because I know we've already talked about this. So again, what's this course about? If you're got an interest in blockchain technology, if you're interested in hashing, consensus, transaction security, and even how blockchain works, this is the course for you. And I've said it every week. We're hopefully going to answer that question of, if you're at a party and someone says, so what is actually blockchain? What does that mean? You'll be able to give an answer on what that is and let everyone know, hopefully, exactly how it works, excuse me. So getting value from this course, business leaders, professionals seeking to understand how blockchain works, general learners and public. And if you know a little about cryptocurrency, I'm sure everyone out there these days knows what Bitcoin is and cryptocurrency and crypto exchanges. This is going to give you some fundamentals to understand why it was created, how it was created, and the background to it. Week one, really important. What is blockchain? We broke down how it works, how hashing works, and some previous examples of blockchain. Blockchain is, and I'll say this again, it's a combination of different technologies. It wasn't just, whoops, there it is. It was, let's take a piece of this, let's take a piece of that. And it was put together, and that was how blockchain was originally created. So week two, we looked into cryptography hashing, how we can do prove something exists without showing that information. We looked at consensus mechanisms, proof of work, proof of stake, and their roles in validating. And then we looked at the consensus types as well, some trade-offs. Last week, we looked at some architectures, blockchains, private versus public. What's the use cases for them? We delved into smart contracts, and I know that was a particular topic that people were interested in, and hopefully we've covered that. And if there are more questions, obviously ask in the forums. We looked at off-chain and on-chain a little bit of NFTs in there, and then we looked at how they could integrate with other systems. Now, this week, we're going to go, if you've been craving for technical, we are going a bit technical, and hopefully the last 3 weeks have prepared you for what's going to come today, because we're going to talk about a really cool subject called zero knowledge proofs, or ZKM, or ZKPs, I should say. And we're going to talk about the security considerations. We're going to go a little bit deep into some of the things I've talked about in the consensus layer, and I've done that in order to explain how zero knowledge proofs might work. We're going to look at interoperability, how you can actually interop between different blockchains. We're going to look at some security considerations, some challenges, and I've got some examples of some future learnings and resources to potentially look at. Obviously, I'm going to say this again at the end, blockchain is constantly evolving. So in 2025, these are the things that we're going to be looking at. But this course might need to be refreshed in a couple of years. So getting into week 4, we're going to talk about Ethereum. And Ethereum is obviously a type of blockchain. And if you're not familiar with that, we've talked about it in the last couple of sessions. But we've discussed in the previous weeks the consensus mechanisms such as proof of work, and I've written there POW, POS, and proof of stake. And I encourage you to go look at that if we're not going to cover that this week, but we talked about it last week. And Ethereum transitioned from a proof of work, and proof of work is what Bitcoin still uses, which uses CPU intensive miners, and that's the actual people say, oh, blockchain's so power intensive, and that's actually because of the consensus mechanism of proof of work. But in 2022, Ethereum converted to it. It was in September. It had been planning for a couple of years before that, but on that date, it transitioned over. And prior to that, it actually used miners and nodes, and people were using GPU cards to mine Ether, which is the coin part of Ethereum. But after this, I'm going to say they called it the merge. A new layer kind of came out, and I want to describe that in the next slide. So sometimes blockchain, and I'm just going to talk about layer 1 here. It's called a cake, and it's made up of different layers. So it's a very delicious cake. And we've got here that there's an application layer, and I'm going to go into all of this. There's a consensus layer, which we've talked about. There's a network layer, there's a data layer, and there's a hardware layer. And this is what's considered parts of the cake. So all these elements here, I'm moving my mouse, hopefully you can see it, make up layer 1 of the cake. So we talked about consensus. Why? And consensus mechanism was part of the cake in that previous one. Well, Bitcoin does all of this in one section. So it's not to say that Bitcoin doesn't have a consensus mechanism. It does, but it's baked into the cake. It's not its own separate layer. It's a chocolate cake. It's all mixed up. It hasn't got separate rainbow layers, if you wanted to take that previous analogy. And it handles all the transactions, the blockchain creation, sorry, the block creation for the mining part, and all that in one bundle. And that's probably the wrong word, but that's how it does it. And if we compare that to Ethereum post-merge, so after 2022, it has 2 distinct separate layers. One's called an execution layer, which runs the virtual machine. It's an EVM. I won't get too technical into that, which processes the transactions and maintains the state of the network. And then you've got the consensus layer. So it's an actual separate layer that's different to the execution layer, where in blockchain it's all mixed, and in this there's a separate layer. And it handles the validation coordination, block proposals, the block fidelity, and the proof of stake mechanism. Now, what I've done is I've done some examples here. So what happens on these different layers? Well, the hardware layer is literally the physical machine itself, the computer itself that is running this node, or perhaps it's a cloud instance, but it's the actual base property, base hardware that's running it. We've got the data layer, which it's the local storage of that node. It stores the blocks, the transactions, and cryptography data. The network layer, it's communicating with the internet. So it communicates, I should say, between nodes, not necessarily the internet, but it is. We've got the consensus layer. We've talked about that. It decides who's going to do what. It's the whole consensus mechanism, the whole trust mechanism built in this case, Ethereum. And we have the application layer, the things that sit on top of that. And they can be smart contracts, they can be dApps, they can be wallets, and things that you might want to do or interact with a blockchain network, or Ethereum in this case. And if you are very technical and you do IT stuff, it's very similar to a TCP/IP stack, in the sense that there are similar layers. You might see that on the application layer of TCP/IP, you can see where the applications are running, and it's a similar concept. It's not identical, but it's a similar layered concept where the smart contracts will run. And if you look at the link physical going right down to the bottom and the hardware layer, it has similar properties. There's a transport layer which is similar to the consensus layer. I mean, it doesn't have the complexity of a consensus layer, but it does make sure things get routed correctly and packetized in the right way. There's the network layer, obviously, that's similar to that, which handles all the communication and the routing between different addresses for TCP/IP and different nodes and point-to-points for Ethereum. So Ethereum uses all the 5 functional layers, unlike Bitcoin, where it's all in one big box or one big cake, you could say. And the execution layer handles the what happened. And the consensus layer handles who agrees it happened and when. And that's the trust layer that we've talked about for the last couple of weeks. So it's sometimes called the cake, and things on top of the cake. And we're going to start to get into what's called layer 2. Layer 2 Ethereum, you may have heard it. If you've done any kind of cryptocurrency, you may have seen applications in the apps that you've used or wallets. Even if you're just talking about different games or different functionalities or different bridges or different ways to swap things, you may have heard the concept of it's a layer 2 application, or it's a layer 2 thing that sits on Ethereum. So layer 1 is sometimes classified as the cake. It's the actual piece that holds everything together, and it's made up of course, the execution and consensus layers with all the 5 layers inside. And layer 2 is considered the icing on the cake, or the frosting if you're an American. And games sit there, decentralized finance platforms sit there, NFT marketplaces can run there, and they can run decentralized without having a server as well. So, and this is important because this is where most, and I'm not going to say all, zero knowledge proofs operate as well. So layer 2, I've written there, is where most user interactions happen because it's the cheapest and the fastest. So we're going to talk about this in a second, but you can actually reduce the cost of interacting with layer 1 by doing some processing in layer 2, and then doing the finalization of that process in layer 1, costing you, instead of 50 transactions, it might cost you 1 transaction because you've done the processing externally to the entire network. So it's a little bit like off-chain, but it's not. It's on-chain, but not off-chain. So excuse my crude graphics. I haven't got a graphics master's degree or anything, but layer 2 sits above the entire layer 1 Ethereum stack in Ethereum. And it handles such things as, and these are really important for this week, channels. And channels are layer 2 scaling solution where 2 or more participants interact off-chain and only settle the result on-chain. And that's exactly what I was just saying. And a very, very good analogy would be if, and I'm not encouraging anything like this, if you were to run a poker game and you had a buy-in. So you bought your chips or you bought your ether or your whatever your cryptocurrency is. At the start, you played your game, people won and lost, and at the end you finalized. So instead of doing 50 rounds of poker and doing 50 transactions, you only do two in and out. And that's just a very loose example, but that's an example of how channels can work and how layer two can save money, or save fees, I should say. Rollups, rollups bundle transactions together. This is similar to hashing a whole series of data, but in this case, it's actually rolling up a whole series of transactions, and it does that off chain and puts a single proof to Ethereum, reducing the cost. So rollups are very similar to what we've talked about in the previous examples, where we're going to hash potentially off chain data, an image or something like that, and place it in the blockchain. And in this case, a rollup is actually a mechanism that's built into Ethereum. Bridges, we're going to talk about this as well this week. It allows assets and layers to move between Ethereum and other blockchains or other layer two networks. And I know a lot of people were like, well, doesn't that break the hash and all that? But we're going to go into that and have a look how that all works. So the really, really interesting topic, zero knowledge proofs. And in the digital world, and I'll give some background to this, proving something often means revealing everything. So to prove your age, you have to show your ID. And if you have ever tried to KYC, which is know your customer, or identify yourself, or sign up to a cryptocurrency exchange or anything like that, you know you have to take a photo of your passport or take a photo of your driver's license. And some people aren't comfortable with doing that. So in another example, to prove your income, you have to show a bank statement. To prove a transaction happened, you have to show your wallet or a bank account that I transferred this, I did that. So there's all this personal information that you have to show in order to prove something. But, and I put this in bold, what if you could prove the fact without exposing any of the data behind it? And what I've done here is, zero knowledge proofs let someone prove a statement is true. So I could prove that I'm over 18 without showing an ID. And I've written there, but wait, didn't we discuss this with proof of existence? Well, let's recap. Previous to this, we've discussed, we know how to prove something exists without showing it. We know something existed at a certain period of time, and we know that it hasn't been modified. That's all because we've hashed it and we've put it on the blockchain. We can point to it in a public arena and no one can claim otherwise, because there it is, there's the hash. And it's decentralized, so it's definitely out there. No one's lying to us. But what happens when we need to prove that that hash equals this thing? You have to actually show it. Well, enter, I guess, proof of existence. And this is an example of proof of existence versus zero knowledge proof. So this is what we've talked about. And I thought in describing zero knowledge proofs, we had to go through hashing, we had to go through blockchain, we had to go through all of that. So hopefully this is a good combination of how zero knowledge proofs combine all those things and build on the previous weeks and examples. So proof of existence and ZKPs both allow you to prove something is true without revealing the underlying data. Proof of existence proves a specific piece of data existed in a certain state in a certain time. So you can say, I've hashed my newest invention, but I'm not going to show you what it is, but there's the hash for it out there. But you, in zero knowledge proofs, you can actually prove a statement is true. I am over 18. I have voted. I do have $10 in my bank account. I did pay that person, etc., without showing that information. And you can think of it as, I can prove I know the answer without showing it. So, and here's some examples. We've just talked about this. Proving your age without revealing your birth date. Showing your income is over a threshold without sharing your payslip. proving a transaction is valid without revealing addresses or amounts. And proof of existence is I would say, perhaps a basic version of zero knowledge proofs, because it proves something without revealing it. But zero knowledge proofs takes that idea further. It lets you prove complex facts privately and securely. And zero knowledge proofs can prove I know something or I did something without revealing what that is. I'm going to talk about this a bit later. And governments are very, very interested in this right now because they understand the problems of personal identifying information, that being lost. And if they can not have to have that information and you can prove something exists without having to share it, it's actually something a lot of governments all around the world are investing in right now. So it's a very, very interesting topic that's connected to blockchain. So here's an example, zero knowledge proof, proving your age without revealing your birth date. So this is the example flow. There has to be a trust mechanism here. So for example, if the government is giving out an ID or a passport, they are the trust authority. They are saying to the rest of the world, this citizen here is this age, was born on this date. So in this particular case, if we're doing an over 18s check, which is legal age in Australia, the government would sign a digital credential saying that you're born, for example, in the year 2000. You would store that credential in a digital ID. And if you've ever looked at perhaps MyGov, or if you're in Australia, it's a digital government wallet situation. They actually have a wallet in there. And I wouldn't be surprised if in the future, perhaps this comes along and is available there. But, I'm speculating there. I have no inside information on that. So a gambling website asks you, how old are you? Are you over 18? Can you come and use this site? Are you of legal age? So you can generate a ZK proof from the signed credential and share that with the in this case, the gambling website. And the verifier can check that. They never saw your birthday. They never saw your ID, but they know that this is cryptographically signed and proven that you are over 18 because there's a trusted entity saying that you are. So it's essentially the same as walking into the casino as a physical person and giving them the ID, and the security guard looks at it and sees it and gives it back. But in this case, you can just show your pass and say, I am over that age, and this proves it. So who could be issuers of this? Well, we need some trusted entities here. And obviously, if you've got an issue with any of these issuers, you might have a problem with this whole concept, but you can generally trust the government to handle a passport, handle an ID, handle birth certificates, etc., death certificates, marriage certificates. So you could prove your marriage. You could prove that, hey, unfortunately, this person has passed away, and claim on insurance without having to show death certificates and things like that. So a bank lender could generate a particular amount of money to a particular proof to say you had this amount of money. Your employer could prove that you actually worked there. They could prove that if you were applying for a housing loan or a bank loan and you had to prove salary, you don't have to actually prove the salary. You have to prove that you earn over a certain amount, and you could do that. Universities definitely could use this and say, yes, this person did graduate here. They did this degree, or they're currently enrolled. Other platforms, so reputation, memberships, frequent flyer points, all those type of things. And obviously healthcare. Has this person been vaccinated? Well, maybe you don't want to share your entire record. It could be just, are you vaccinated against this disease, or have you taken this particular thing or something? Here's your test results. That all could be rolled up into a ZK proof, a zero knowledge proof, I should say, and prove that those things actually exist without showing any of that information. So, and I've written there, as long as the verifier trusts the issuer. So if someone says, well, I don't trust the issuer of that bank, I don't trust the issuer of that university, then obviously you may have an issue, but in this particular case, a zero knowledge proof can prove the claim came from the issue and meets the requested condition. So as long as the people endorse that, and there is some trust, it's a very, very good way to prove something without actually showing it. I have some examples here because there've been some questions about, hey, what's some real world examples? And this, first of all, I want to say this is it is new. It's been around for several years. In practice, there are some white papers about it. There are some research papers. I do know of, and I mentioned this last week, Miko Me. They do have a white paper there, so I encourage you to have a look at that, which specifically talks about zero knowledge proofs. Immutable has some examples. That's another Australian company that they do NFT marketplaces and some other ZK. I wouldn't say ZK proofs, but other ZK similar stuff. They might do it. I don't know the full range of their products. I'm sure they're very smart people and could do all this anyway. And there was an article I found from Google who's actually using, and I believe it's just in the UK, Google Wallet to use ZK knowledge proofs, zero knowledge proofs, I should say, to prove an age and store that in Google Wallet. So there's a very interesting blog article there from Google around about how they're rolling that out in the UK. And it's time for questions.
So currently, we've only got a couple of questions at the moment, but David has asked, roll-ups and channels seem to perform the same thing. Just wondering what the underlying or applicable difference is.
We are going to go into it in the next section. So
Ah,
yeah, there's a question coming and the answer will come. So
excellent. All right, so wait and see. Just building suspense there, really.
mm.
Um, uh, yeah, we've got a couple of other questions. I think that the question about ZKPs working with required legalization coming into effect to prove age for accessing browsers, etc. Based on what you've said so far, I would assume that that is correct, as if it's a, an independent age verification system. Uh, it would probably depend on your government's regulations, but what
Well,
do you think?
100%. I mean, Facebook, I believe you have to be 13 to use it. That's a terms of service requirement. So the government might mandate that if you're over, you can only join a social media if you have this zero knowledge proof that says you're over 13 or over a certain age. So um, yeah, definitely you could do that. Like for example, and I'm not advocating this, but if there was a horror movie that happened to have an R rating and you need to be over 18, Netflix could connect to your wallet and say, yep, this person's over 18. So if you think about all the places that might be convenient in order to allow or disallow, but not have to, no one's going to want to, if the government says, well, we have to limit the people that have access to these type of websites because they're for adults, then no one's going to want to upload their user identification. So if they had a way to prove something without having to show something, then that's a great way to do it without exposing any information about yourself.
Great, thank you. Uh, we've got a question from Tim asking, what would happen for somebody with fraudulent profile data?
I mean, that's fraudulent data would mean you wouldn't, for example, you couldn't set up an account unless you had the right data or data. So if you happen to have a legacy account, yeah, maybe, but Facebook, if you're talking about Facebook or social media or whatever, they might just say, well, now you have to prove certain X, Y, and Z. But I would assume that and again, I'm talking about Facebook just for the sign up process, they would trust that the government of Australia, for example, would they've done their due diligence. And if someone presents a piece of proof that uses the issue of the Australian government, then Facebook would assume that That's correct, and that's actually how most SSL certificates work as well. There's a trust mechanism based on who's the issuer as well. So I mean, that's not exactly how it works, but there is a trust mechanism of saying, well, if that company issued that certificate, I'm gonna assume that they know what they're doing. So yeah, I'd say it's similar in that situation.
Great. And Saad has asked if there are any limitations or risks associated with using ZKPs in financial transactions.
I'm sure there is in I don't know of any myself, but that's not to say there isn't any. And again, this 2025, if you're looking at this in a couple of years, I'm sure something has come up, or hopefully not. But I don't know of any, but I'm not going to say there isn't any. So um, I'd say no for now.
None that we're aware of at this point in time, at least, not
Um,
specifically. And
yeah,
one
someone
final
could be working
question.
on it, but yeah, not right now.
Great. And one final question before we move on with the content. Peng has asked, do ZKP models always require a third party trusted by both sides, making the models somewhat centralized?
Interesting question. Um, and I know I've talked about decentralized trust, and this seems to go against it, but you can't really have an issuer. You can't have a decentralized, and again, this goes against sort of other things, but you couldn't really have a decentralized entity or something that verified, for example, a driver's license with your age on it without exposing that to the network. So you could, for example, create a decentralized identification system, but you would have to expose your original document to that service, who then would translate that driver's license, for example, to say that you're above that age. Now, because they don't issue that particular thing, they don't issue the driver's license, it actually goes back to that previous question where what happens if someone uses ChatGPT to generate a fake driver's license and just uploads that? So you can't just straight up have a decentralized system. Someone has to prove that at some point this is a real driver's license, this is a real passport, and the people that are issuing those passports and the people at border control, um, you'd have to assume that you couldn't get a passport, and I'd say 99.99% of the time, without having the right information. So the people, if you saw that you had a digital identity from the Australian government, you could say, well, they haven't had any problems in the past, so I would trust any identity that came from that issuer. So um, that's why it's a little bit different.
Great. Thanks very much. And thanks everyone for your questions. Just a little reminder to post questions for Rich to answer in the Q&A section, which is to the right of the chat section in the menu bar down the bottom of your Zoom screen. And that is the best way to get your questions answered in this. Otherwise, direct them to the forums at learn.itmasters.edu.au for further and future discussion. Thanks very much, Rich.
And there's going to be a little section at hopefully at the end for more questions. So we're going to talk about blockchain security here, and this has been some questions as well. And I've got to say, look, nothing is secure. Blockchain is not bulletproof. It is another way to do it, but in this, I put the question here: you can't trust people. In code, we trust. So the data is locked in. Once it's written, it can't be changed. We know that. That's immutability. Everyone seems the same version. There's no secret edits. There's no central point to hack, but human errors still matter. They still occur. So at this point, humans are the weak point, which sounds crazy. But in an AI world, that's a, that's the issue, and that's through poor coding, poor QA, weak passwords, losing passwords. So if you lose it, if you lose these things, you lose access to your keys, or you've made a mistake in your code. This is where big problems can happen. So it's really, really important to make sure you know what you're doing. You've tested it. You've got it. There's actually third-party auditing services for smart contract, for example, and they'll put a certain guarantee on it. So it's worth investing in that if you have something that's super mission critical and it's decentralized, because once you release it, it's out there and it cannot be stopped. So blockchain does exactly what it's told to do. If you tell it to jump, it will jump. If you tell it to not jump, it will not jump. But the data is locked in, and once it's written, it can't be changed. I say in 2025, there might be future versions where that sentence goes outdated, but ultimately the principle of blockchain is that once it's in, it's never going to be changed. So everyone sees the same version. There's no central point to hack. So security is baked in, but operational risk, poor code, and human error can still break it. So this was a question previous to in the previous section, bridges. So we're talking about connecting blockchain islands here, and what we're doing is bridging lets assets move between different blockchains, and I've written there ETH to Solana, Solana being another coin. And what it does is a bridge often involves locking tokens in chain A and then minting wrapped tokens in chain B. And we're going to break that down in a second. So what this does is it enables gaming, cross-chain applications. Sometimes they're called wormholes, sometimes they're called portals. And they're ways to transfer asset value. And I'm not going to use the word, it's not transferring one-to-one, it's transferring the value. So something's worth $1 on one thing, essentially it's worth $1 on the other. And that's a very loose statement because that's not normally the case. But it's normally you trade one on one platform and then you get one on the other. And then that's the general rule. So a lot of security problems have started with this code because you're dealing with a lot of assets. You're dealing with a lot of tokens, and tokens hold value in this particular case. So there's a lot of trust that's put on these, that the wormholes or the validators or the oracles or even the light clients have been programmed correctly, have the humans behind them audited the code. Is there no vulnerabilities? Is there no exploits if you flood it with this many transactions, or a transaction value of this particular thing doesn't overflow in the code, which then runs something incorrectly and leaks some information. So these are some big situations that have happened, and 320 million, 600 million in asset value has been lost in the past. So I just mentioned locking and wrapping. What is that? So when we bridge an asset, for example, Ethereum or ETH to Solana, the original tokens aren't moved. What they are is they're locked. So let's just say we're transferring 10, and let's just say the equivalent was 10 on the other chain. Those tokens, or in this case, this coin, is moved into the smart contract. In this particular case, the smart contract acts like a wallet, and I'm just being very general here to explain it. And the smart contract acts like an escrow. So it holds on to your ether and prevents it from being spent. So it puts it into its own little box. And that's why it's actually quite a big target for hackers, because there's a box out there with some code attached to it that has value in it. So it's a very high value target for particular hackers. So, and that locked amount is recorded publicly on chain for transparency and auditability. So we know that this particular amount was transferred or to another via a bridge. So after the lock is confirmed on the source chain, so where it's coming from, the bridge mints, and mint means create new tokens on the destination chain. So that means if I'm transferring Ethereum or ETH to Solana, on the Solana network, we'll get something called wrapped Ether or Ethereum or wrapped ETH. And these wrapped tokens represent a claim on the locked tokens. So you actually, and it's fully backed one-to-one. So if you transfer 10, you get 10. Obviously, there's different situations, but that's 99% of the case. And you get 10 tokens that represent the locked value that's back on Ethereum. So you can actually trade these Ethereum wrapped tokens on Solana, and the value is still there. So you can, and that's just written there, you can wrap these tokens like normal and trade them. So you can actually say, well, here is 10 wrapped Ethereum or ETH, I should say, and buy something with it, trade it. And if ever you want to get your money back, just go back through the portal and you'll be able to get your original asset back. So again, sort of putting together trade the security considerations of this, wrapping introduced trust assumptions. And this has been the problem where the bridge must stay secure. So if you're holding a bunch of assets and it's out there decentralized, it better have really good code. So if the bridge is compromised, all the wrapped tokens or all the assets can be either become unbacked, meaning they've been stolen or they've been lost. So the code is broken and it can't be fixed and they can't be recovered. That means the wrapped version instantly goes to zero because you can't trade them back to the original value. The IOU, it's sort of a strange example, is now no longer valid. So decentralized, trustless bridges uses cryptographic proofs, and others rely on multi-sig, multi-signature, or third-party validators to try to validate all of this, but it has to be done correct or you'll run into trouble. So starting to head towards the end here, the key challenges of blockchain in general, and this is sort of starting to wrap up. The main problem with blockchain, and I'm sure if you look this video first and didn't look at the other three, blockchain has a steep learning curve, and it's not necessarily steep for everyone, but if you're coming in from fresh, it's got some complex concepts. I've written poor UX, meaning a lot of it is still in code, a lot of it's command line, a lot of it is not necessarily in the browser. And that's slowly changing, but if you really want to get deep, you need to be almost a little bit of a coder. And not necessarily a problem, but there's constant change. So what you know today, what you've learned in this course, I would encourage you to keep refreshing your memory and your knowledge, and keep learning because blockchain is changing a lot. Uncertainty, regulatory uncertainty, laws in different countries, they classify, if we're just talking crypto, as taxable assets. They might classify them as a trade. They might classify them as nothing. So there's a little bit of question mark around regulatory uncertainty. I know Australia this year has come out with some new documentation regarding regulatory for blockchain. I don't know if it's going to address most of the topic, but it's mainly meant for crypto. But it's good that some governments are looking at this. Some governments are more mature in terms of they've got more evolution of that, and some are still wait and see. Security vulnerabilities, there's always going to be a problem. This is not necessarily an issue of blockchain, but because it's so public, because it's so decentralized, and because there's real world money attached to, I shouldn't say real world money, real world assets that have monetary value attached to it, that they become a high target. There are some scalability bottlenecks. There are newer networks that come out, but it seems, for example, Bitcoin is a slow mover. They do have code updates, but other networks do have, I wouldn't say better systems, but newer, more advanced systems that use less CPU, faster, are less cost effective, are less power intensive potentially. So what's the future of blockchain? Well, the future isn't built on trust, it's verified on chain. And this is a little bit of what I believe, and hopefully you've taken away some of this. So self-sovereign identity, meaning you can now control your own identity. You don't have to share pieces of paper or passport information or photos of this and photos of that. So there's no necessary central authority needed for potentially storing this information. Obviously, there needs to be an issuer, but there doesn't need to be these companies that store this information. Users can prove who they are without revealing any information, prove you're over 18 without showing the birth date. I believe the future powered by blockchain and zero knowledge proofs for privacy and verifiability. They're two big things that will be emerging. And I think people won't even realize that it's not done on blockchain. But hopefully everyone in this course will know that. So this is useful for KYC. KYC is know your customer. KYB, you might have heard, is know your business. They're used for companies that need to identify their users. Most banks have to KYC their customers to prevent money laundering and things like that. But this is good for showing something without having to actually show you the real information. Educational credentials is another great one. University degrees, passing, did I do this course, student IDs, medical records, and of course we've talked about voting. And this obviously reduces fraud, improves privacy, and works across borders. You don't have to send something. If you were to wanting to gamble in a US state that required you to be over 21, they might not know what an Australian passport looks like. But if they trust the Australian government to issue a zero knowledge proof, then it will work across borders. So there's some trust there as well. It also is very hard to, if we're talking about that previous question, it's very hard to make a fraudulent version of that. So it brings trust in that degree as well. Emerging in, I guess, in 2025, possibly in the future. So blockchain basics. So I think the concept of blockchain will increase, consensus as well. So please have a look at any courses that maybe IT Masters might do in the future. Binance Academy is another one. I encourage you to learn, if you are a programmer or interested, to learn Solidity, Rust, or Move. And then blockchain security, formal verification. Have a look if you're in the security industry, how this could help you. If you're interested in how the systems work, have a look at I've listed some other different blockchains that do have active communities on them. They do have good documentation. And I really encourage you, if you are interested, to join these communities. They're really, really welcoming, and they really, really will help you to write stuff. And they're not standoffish at all. They're not unlike other communities. They're very, very helpful. I've always found the blockchain community and the blockchain devs to have the coolest parties, by the way. So if you ever get invited to a Christmas party, definitely go. But they have the best time. They have the best fun. They don't take themselves too seriously, and they write cool stuff and they make cool stuff. So I encourage you to get involved if you can. I've written emerging techs, obviously zero knowledge proofs, layer 2 rollups, decentralized personal identifier, off-chain DAOs, and I've written IPFS, which is decentralized file systems. I encourage you to have a look at those as well. So wrapping up week 4, I wish we could go on more. I told them that I could write 100 slides, but so zero knowledge proofs proves it's true without showing the data. Security considerations, blockchains are secure, but they're not immune. They're just like everything else, but they do have the mechanisms to be secure. The humans are going to be the weakest point. bridges connect chains, but they also create a little bit of risk. But there's a lot of opportunity there. Challenges and opportunities. There's big potential, and I encourage you to keep teaching, and I encourage your friends to come and do this course if they can, because I hopefully broke it down, and I'm leaving you guys at a level that allows you to pick it up in other places and with other communities. Future learning, explore, research, reach out. There's an awesome blockchain community out there. That's what I've said. I should say explore, not explorer, but anyway. So thank you. This concludes the course. I want to thank everyone that came. You were totally awesome. Everyone that showed up every week, put the questions in the recording, put the questions in the forum. So some really, really good discussions. And I encourage you to keep researching blockchain, keep learning more. And I want to say my parting thought is that, and I said this at the start, blockchain seems to reinvent itself every 18 months. So what was once expensive or impossible does become achievable. So keep researching. The future rewards the prepared. So if you're learning from this and you want to go further, I encourage you. And I leave you with blockchain is not just cryptocurrency, and hopefully this is a great foundation for that. So with that, we have our final questions.
Fantastic. Thanks everybody as well for all of your participation. Um, and honestly, thoroughly endorse Richard's statement about blockchain parties being weirdly cool, like
They're
shockingly
very
so.
awesome.
Yeah,
I'll try to get to some.
yeah. Highly recommend. So we've got a question asking, in the future, does ZKP allow me to, instead of carrying a driver's license card, carry, for example, a digital credential stored on the phone that uses cryptographic protocol to prove specific facts about me, but not those facts itself? Is that something that you see as a possibility in the future?
Yeah, 100%. Like you could get to um a pub or a alcohol establishment, and it might be just scanning a QR code, which you actually do when you enter in some clubs as well. But you could actually prove it offline because you've stored that credential in your phone. Um, I, I guess even for if you had a traffic stop and you didn't want to show your birthday, but you wanted to show that you had a driver's license, you could potentially do something there. But yeah, there's definitely a lot. If you have a think about it, there's a lot of examples where you need to prove something, but you don't need to show all the information on that. And you might not want to show the address that you live in because your address is on your driver's license. So that's a way of proving one particular part of this. Actually, there's a good point there. Like, are you licensed to drive an automatic car or a manual car? And you don't want to show that you're 80 years old, for example. You could do that. You could prove it. So if the trust mechanism, the trust issuer has allowed that.
Great. And I suppose further to that question, uh, if instead of showing your driver's license, you were to present digital proof, which then has to be decrypted, does that not introduce processing overhead?
Um, so I would assume that if you were, say, someone had to see an ID, that the they could prove that it works offline as well. So I don't believe you need to actually validate that back to the original source. You could actually cryptographically prove it was valid outside of that, but that's a very good question. I will have to answer that in the forums.
Great, excellent encouragement for everyone to head along to the forums. Um, Tim has asked, is Swift an example of a bridge? So I believe that by Swift, what is being referenced there is sorry, want to get the
It's the
correct
transfer,
acronym there, the Society for
the
Worldwide Interbank Financial Telecommunication. Is that correct?
That's the old banking system. So I think Swift has reinvented itself. It was if you needed to send $100 to Germany, it would take 3 weeks and go via the Swiss system. Um, and now that's pretty much done instantaneously or within a couple of hours. Or if you use some other systems like TransferWise or Wise, it can happen in 10 minutes. Um, so I don't know what the backing is these days of Swift. I don't think it's a bridge, but they could use blockchain. And I know other systems for money transfer do use blockchain. They would have use probably stable coins to do that, or a very known, a very perhaps a very stable coin, not necessarily a stable coin, but a coin that doesn't have a lot of volatility, meaning it doesn't change very much. But I don't know the answer of Swift. It's definitely not a bridge, but I don't know if they use blockchain. They might, but I'm not privy to that information.
Right. Very interesting to find out. We've got a few people asking if you'd be able to share a link for beginners in blockchain as well as on ZKP. That might be one that is best directed to the forums. Is that right?
Yes, as I could put some good research examples up, I'll post that in the forums. But it is relatively new. If you have downloaded those slides, I encourage you to look at the Miko Me white paper. It is a company that I'm not associated to. It's an Australian company, but their white paper was relatively good, and they were talking about it very early. I think in 2017, I believe. So they were very, very early talking about zero knowledge proofs. So that's a very good article. But I'll post some more up. Yes.
Fantastic. Thank you. Look forward to seeing those in the forums. Are there any of the other questions that you are interested in answering for us, if you'd like to take a look?
Having a look. How did I get into crypto? Um, I got into it when it was 30 cents, but I didn't buy any. So how silly am I? I know I knew about it very early on, and uh, I was interested in it because it's such an interesting topic, but it evolved quite quickly, as everyone knows. So, um, and I was having a look at some of the other questions. Blockchain is certainly a double-edged sword. The technology provides an opportunity to enable any criminal. How does one government organization regulate to least inhibit proliferation of abusing the technology? Um, I guess the question is, how do you keep the government honest? How do you make sure people aren't fraudulent with it? It's really quite simple. Obviously, there's existing mechanisms to do this. They're not foolproof, but those existing mechanisms don't need to change. They just need to create a digital version. And obviously, you're going to have the same problems of fraud that may exist in I guess, a paper version that you might have in a digital version. So, what you want to make sure is that the mechanism that, for example, if a hospital is saying this baby was born, here's the birth certificate, that hospital is valid. I mean, that sounds crazy, but you've got to make sure that the supply chain of that information is correct. So if you've got a strange hospital that produced 20 birth certificates in the same day and they all had the same timestamp on it, then perhaps the government wouldn't trust that hospital anymore. So there's this, I guess, a central circle of trust that needs to happen. And then once that happens and the entity trusts the information within it, theoretically, you can then trust that entity because you know that they've done their homework in doing it. So once that trust has been made, then you could do it. So I don't think there's any way to 100% stop it, but I think that it's a good way. There's also, I'm assuming that if there was, for example, some fraud that happened and there was a central authority that you did check that signature with, you could revoke it. So if you could revoke that um, particular proof that said you're over 18, well, you could, and that was centrally checked. I'm sure an offline version might work for a couple of days, but you could perhaps revoke that. So and you couldn't necessarily revoke a forged passport or a forged, or not a forged one, obtained fraudulently, I should say, version of a, a piece of paper or a card or whatever. So there's some interesting things there.
Great. And I think that this is probably where we're going to have to leave things for now, just for time. Uh, for everybody else with all of these fantastic questions, as usual, just direct everyone to the forums. There's fantastic ongoing discussion there with Dr. Rich. For people that did have some questions about the exam, uh, those questions hopefully will be slightly answered, letting you know that the exam will be available fairly shortly, possibly by later on tonight, certainly by tomorrow morning. Your results will be available immediately, and you will be provided with the certificate upon completion of that. You have one attempt in 60 minutes. Um, one attempt in 60 minutes that should be uh, able to gain you that certificate, which will be automatically downloadable upon completion. For everybody else, if you have any questions, feel free to email shortcourses at itmasters.edu.au. And as well as please do check out that eligibility link, which John has helpfully put in the uh, in the chat down below. Just wanted to check if people can hear my audio. Sorry, I seem to be having a bit of a technical issue.
We can hear you.
Oh, fantastic. Sorry. Um, Yes, so that should answer people's questions about the exam. It is a multiple choice exam for 60 minutes. Um, Again, please do check out eligibility on the IT Masters website if you are interested in ongoing study in this area or similar areas. We are always interested in chatting to people about what they may be eligible for, both in terms of entry to the course as well as credit for recognition of prior learning as well. And as we've mentioned, Dr. Rich is one of our fantastic mentors. We have many other mentors who are just as knowledgeable in their respective fields as well. So please do get in touch. Can email eligibility at itmasters.edu.au for that. Um, we will be back with more short courses in the future. You'll have those announced to your emails. Um, and for now, I believe that is pretty much everything. So, massive thanks to everyone for participating over the last 4 weeks. Big thanks to John for moderating and running the back end. And of course, a very big thank you to Dr. Rich Lane, who has been our wonderful mentor, extremely knowledgeable, very engaging, very interesting. Hopefully, he'll be back to do some more short courses, possibly in the future. But otherwise, you can catch him. In our longer form courses for the graduate certificate or the master's programs with ITM and CSU. That should be wrapping pretty much everything up. Was there anything else that you'd like to say to close us out, Dr. Rich?
No, thank you. I thoroughly enjoyed it, and I hope everyone got something from it.
Great. I certainly did. So thanks very much. And hopefully we'll see you again in a future short course or as one of our students. Thanks, everybody. And depending on where you are, I suppose good morning, good evening, good afternoon, or good night. Take care, everyone. Stay safe.